Hello, this is Rick from MathX, and today we'll be doing number 19 from the 2020 AMC 10B. In a certain card game, a player is dealt a hand of 10 cards from a deck of 52 distinct cards. The number of distinct, unordered hands that can be dealt to the player can be written as a really big number. And what is the digit A? Now this problem is kind of different because when they start out with cards, I was gonna think that they're gonna ask us to find out the number of plays, but they did. They found it out for us, but we had to figure out the missing digits that they were too lazy to write in there. So the number of ways to choose 10 cards from a deck of 52 cards is 52 choose 10. I know, I'm a genius, right? And yeah, it's just that simple. It's just 52 choose 10. For those of you who don't understand that, search up choose combinations and permutations to understand. We use choose in this case because order doesn't matter. If we pick a king and then a jack, that's the same thing as picking a jack and then a king. We're not going to count that twice. So the same kind of idea applies here. That's why we're doing choose. And yeah, that's it. But we already know that because this value is just 52 choose 10. We want to find out what A is in 52 choose 10. So 52 choose 10 is equal to 52 factorial divided by 42 factorial times 10 factorial. And 52 factorial is 52 times 51 times 50 times 49 times 3 times 2 times 1. And it's the same thing with 42 factorial. 42 factorial is 42 times 41 times 40 times 39 times 38 times 5 times 4 times 3 times 2 times 1. So basically, these are just anything factorial. It's just the product of itself all the way to 1. So in this problem, all we need to do is multiply. But if we multiply all those numbers, we're going to be here for quite some time. And AMC 10 is only 75 minutes, and there are 24 other problems, so I don't think you can do that. Lucky for us, we can already cancel out 42 of these numbers. Because this is just 42 times 41 all the way to 1, this also has 42 times 41 all the way to 1. Because 42 is less than 52. This is good. At one point in this series, we're going to get 52 times 51 dot 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 42 times 41 dot 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 all the way to 1. So we can automatically cancel this out, and we'll just be left with, on the numerator, all the numbers greater than 42. So we get 52 times 51 times 50 just fits in. And then we put that over 10 factorial. So 10 times 9 times 5 times 24. Yeah. Well, 4 factorial is just 24, so I'm going to leave it like that instead of writing 4 times 3 times 2 times 1. Because 4 times 3 is 12, and 12 times 2 is 24. So then we just need to find a way to find out what A is from this computation. Well, A is in the first 2 digits. So if we take and mod 100, we find out what the remainder of this big number divided by 100 is. And if A is 0, that's going to be 0. But if A is anything else, we're going to get the digit of whatever A is. So if we take this entire figure and mod 100, we'll get what A is and the 0 after it. So we just need to do the same thing here. We need to take this entire figure, mod 100. So let's simplify it down a little bit. So we have 24 on the denominator, and we have a 48 on the numerator. So we can cancel these out and get a 2 here. We have a 10 and a 5 on the denominator, 50 on the numerator. Let's just get rid of those overall. We have a 7 on the denominator, and we see we have a 49 on the numerator, so let's get rid of that. 8 on the denominator, but we don't have any pure multiples of 8 left. So let's just take a 2 from 3 numbers. 44, which leaves us with 22. 46 leaves us with 23. And 52 leaves us with 26. Next, we see we have a 9 on the denominator, and we have a 45 here. So let's just get rid of that and put a 5 on top. And finally, we have a little 6 down here. Once again, no pure multiples of 6 up here, but we can take a 3 from 51 and a 2 from 26, giving us 17 and 13. So then we're left to find the mod of 13 times 17 times 43, and we have to find mod 100 of that. Yeah, I'm not doing that. But wait, 100 is just 4 times 25. So if we find mod 4 of it and find mod 25 of that, we can use like Chinese remainder theorem to find what that is in terms of mod 100. So let's check. Mod 4, what is this number mod 4? Well, I think we already have a 4 in there because we have a 2 here and we have 22, which is 2 times 11. So we have a 4 times this huge other number. So this number is already a multiple of 4 because we have 2 2's in there. So we can already say if this thing's a multiple of 4, it's already 0 mod 4. So now we just need to look for mod 25. Okay, that's where this gets irritating. We're gonna have to start bashing a couple numbers out. 13, we can express that as 13 mod 25. 17, we can express that as negative 8 mod 25. Right, because 25 plus negative 8 is 17. Next one we can do 7 is 7 mod 25. So I'm just going to keep the 25 here to the side. I'm not going to write mod 25 every time. 2 is also 2 mod 25. 47 is negative 3 mod 25 because it's 3 away from 50, which is 0 mod 25. 23 is negative 2 mod 25. 5 is 5 mod 25. 22 is negative 3 mod 25. And then 43 is negative 7 mod 25. So we have to simplify this once again to find out what all of these are mod 25. So let's look at negative 7 and positive 7. Their product is negative 49, which is 1 greater than negative 50, which is 0 mod 25. So the product of this is going to be 1 mod 25. Negative 8 times negative 3 will give us 24. 1 below 25, so negative 1 mod 25. 13 times negative 2 is negative 26, which is 1 less than negative 25, which is 0 mod 25. So we know that this is negative 1 mod 25. So then we're left with 2 times 5 times negative 3, which gives us negative 30. Well, negative 30 is 5 less than 25. So it's 20 mod 25, because it's just 5 less than a multiple of 25. So it's 20 mod 25. So negative 1 times negative 1 is 1. 1 times 1 is 1. Oh my god. Intense math right here. And then 1 times 20 is 20. So we get this entire thing to be 20 mod 25. Now we use the Chinese remainder theorem, which in this case of only 2 terms means bash. We're looking for the smallest number that is 0 mod 4 and 20 mod 25. It's 20. Because 20 is a multiple of 4, and it's also 20 mod 25, because 25 times 0 is 0, and then 0 plus 20 is 20. So we see that this huge number, mod 100, is 20. That means that the last 2 digits are 20. So A0 is equal to 20. That begs the question, what is A? What is A? I don't know. Yeah, obviously it's 2. Okay. So we have A0 is equal to 20. So then A is obviously 2. So all in all, this problem isn't that hard. Like, we just did some computation, used some take a couple mods, but it was a lot of bashing, which really made it unappealing for me when I took the AMC 10B. On this problem, you should try to work smart and minimize the amount of bashing you do by choosing select numbers to multiply together. When I was left with all these numbers, if I multiply them all up, I would have spent like at least half the test just doing that on this one problem, number 19. But if you multiply smartly, you can really save a lot of time and still get the right answer.